So I need to find this address on the network to send to it. And that's what's happening in these first two frames with ARP. And this happens all the time. I'm going to minimize this. And now look, I'm sending out what's known as a broadcast because I don't know where that gateway is, believe it or not. All I have is the IP address configured in my TCP/IP settings, but I don't have the physical address. That's the burned-in network card address of that default gateway. I have to find it. The way I find it is I send a frame out to the entire network. That's why this first frame or packet is a broadcast. And I'm saying who has 192.168.1.1. And then it says here in the summary, tell 192.168.1.107. Well, guess what? That's me. So I'm asking the entire network who has this IP address, and whoever does, send it back to me. In this second frame, that's what happens. The gateway receives that packet because it was sent to every computer on the network. That's basically what a broadcast is. And it's going to basically tell my computer that this is the physical address 002369255338. That's a hexadecimal, base 16 address. All computers with network cards have these burned in addresses. Let me see what mine is. I'm going to go back to the command prompt, toggle here with Alt Tab, and I don't have to even type another command. I can see it right here. You see right here where it says physical address? This is the physical address of my network card. It's not this one we're talking about. Those are different. You see 0023, mine is 0012. This is my burned in network card address. And what happens is, in order for these packets to move on the network and reach their next destination, they have to know this MAC address. So my computer doesn't know the MAC address, the physical media access control address, I should say, same thing, without sending out that broadcast. So once my computer learns this physical address right here, it can then finish the packet and send the next set of packets, which is the DNS. So I hope that makes sense, but the bottom line here is, if I had this DNS server on the same network as me, I would not need to send it to the gateway. I would actually send it to the host directly, because the host would be on the same network as me. I would send out the same type of ARP broadcast, but it would be for the DNS server on my network. Let's say the DNS server was 192.168.1.20. If that was the DNS server, I wouldn't have to send it to the gateway because the destination's on the same network as me. When I apply that subnet mask to the gateway, it would be 192.168.1.0 being the address. So basically, we need to now forward our query, which is DNS, out to the network, and that's why we got this address of the router, so we can send it out. And that's how the router can actually go out and forward it to the next network, to the next network. We'll study that later, to get it to this IP address 172.27.35.1, which is listed here as my DNS server. So what that is happening here is I'm sending out a query. Before I can connect to the San Diego State University web server, I have to actually get its IP address. So what I'm doing here is I'm sending out what's called a standard query, and I'm asking what is the IP address of that site. And you'll see it's really just two frames. After I do that, that DNS server 172.27.35.1 goes out. It is a fairly complex process, but the user on my computer doesn't have to worry about that. All they have to do is sit there and wait for the answer. The DNS server that you communicate with directly for your internet provider, which is the case here, goes out and goes through a process to get that IP address. And basically, once it gets that IP address, it sends it back directly to my computer. So here is the actual response. It says the standard query response. A means a host record. Basically what it's saying here is 130.191.8.198 is the San Diego State University web server, and once I have that, I can then, in the following frames 5, 6, and forward, will connect. That'll be done in another lesson. But to finish up this lesson, I want to show you that this is truly the San Diego State University web server by going into, let's use a different browser, Firefox, and I'm going to type in that IP address in my address bar and see if I actually get the San Diego State University website. If I do, then I know I did it right, and that just proves the point that we're getting the IP through DNS, and then we can actually connect to it behind the scenes. All this stuff is happening behind the scenes, and the user never would even know it unless they were studying this. Okay, so let's try it. I'm going to make this screen a little smaller, so we can see both things at once. I'm going to go ahead and minimize that prompt. Here we go. So I'm going to type this IP address in and let's see what we get. HTTP 130.191.8.198. So I'm just typing the same address I'm seeing here in the standard query response for DNS. And let's see what happens. And there it is. See? I got the San Diego State University website because DNS provided me that IP address out of its database, and now my computer's learned it, and now I can connect to it. You would never want to use these IP addresses directly when you're typing in addresses because they're too hard to remember. Also, they change over time as computers and servers get moved to different networks or different locations, different buildings. But that just proves the concept of DNS and how it works. Okay, I'm going to go ahead and stop here. Actually, I do need to talk about one more thing before I stop. I need to talk about where these protocols reside in the 4-layer model. Where ARP resides, it's really pretty much between the data link layer, I shouldn't say data link, that's the OSI model, the network access or link layer is what we call it in the 4-layer TCP/IP. As you know, that's the bottom layer, layer 1. So ARP is actually layer 1 and kind of between layer 1 and layer 2. Layer 2, as you recall, is the internet layer. That's the network routing layer where you try to figure out what network you're going to. Well, what ARP is doing is it's converting the IP address. Again, in these first two packets we were trying to get the physical address of the gateway, 192.168.1.1. What ARP is doing is it's translating the logical address at the internet layer, that's layer 2, to the physical address at layer 1, which is that MAC address we're seeing here, 002369 and so on. That broadcast, again, is happening between layer 1 and layer 2 to get the physical address sent back to us by the gateway, and then we can actually put the final frame out on the network and send it. The frame we're going to put on the network, by the way, is this DNS packet number 3 here, frame number 3 here. That's what we're trying to do with ARP here. We need to get the address of the gateway so we can send this frame to the DNS server asking the question and then get the answer back. So once we have that answer, you'll notice you won't see ARP again for quite some time because it stores it locally in your computer's cache, so you don't have to keep sending out that broadcast to get the gateway. It stores it there for quite some time. Okay, we're going to go ahead and stop now and pick up in the next lesson.